on the end. You got to go like.
Right. You can go around quicker because you have less.
It's quicker. It's quicker access to the data.
And technically all the time. I mean, it's constant angular velocity. So it's called CAV. So constant angular velocity. They're always going to be at the same speed because if you have 7200, spinning hard drive, it's going to be 7200 no matter what you do. So this spot is still going to pass at 7200. This one's still going to pass 7200. You just got way more property. So it is designed with that in mind, and then later on, it wasn't until the late 90s they broke it down into zones and divided it up according to speed so that they know, like, if I turn off the head here and turn on the head underneath, how much time does that take? Where is the spot that amount of time takes longer to read the sectors than it does for me to come back to the outside edge? And so they find that sweet spot and they design that as a zone. And they actually have a log, they have like a table that actually says these sectors all go together. And I have a picture of it in the book, but that's all it does. It says from LBA 0 to LBA 1, you're on head 1, all your data is fastest here, and you have contiguous space. Which is nice from a data recovery standpoint, because if you get a scratch on a platter, if the data was actually dispersed amongst all the platters, then you wouldn't be able to recover any file. It would be like a RAID array. You lose every other sector, and we don't have that. So we're lucky that we can read from one side of a platter. Whatever's there, we got, at least. It might not be enough, but...
It's neat when you have, talking about the speed with the Apollo and the PC3000, you have that test, drive test thing.
Yep, right.
You see that graph of how...
Yep, I begged him for that. I literally begged him. I told him, I said, so a lot of times when I'm working on a hard drive, I have degradation in a head, and the head isn't as fast as the other heads, but I want to image all the heads that are fastest first. So I wanted him to tell me. So he literally, I sat down, I spent a week with him in Orlando, and then he came to my office, and we spent 3 solid days going over every single thing. Why it all, here it is, what's this bug, what happens, how's this work, why are we going to do forensics on this? And I'm glad he implemented almost every single thing that I asked for, he implemented. I was super happy with finally having the hex box. Remember, he didn't have that hex box for a long time, where you could freeze, you could slide it, you could do, basically what you see on a DeepSpar when you're doing that. And I tell DeepSpar, get the default hex, not the map. Yeah. I mean, you care if you're getting zeros, you care what data you're seeing. You don't care as much about did it copy the whole sector. I want the default in hex. So...
Yeah, that full map view doesn't give you much.
No, I mean, well, it's always a second thought, right? Your second thought is, how much of this drive did I get? It's not the first thought. The first thought is, am I actually getting data? That's the first thought, and it was always mesmerizing. Like when people come in the office and we have 30 of them running, and maybe you see a hex, you see them all copy, and I will walk around and hit the button for everything I started up to be in hex. Dang it. I'm very upset about that.
Yeah, but you know what they're going to do? Then they'll release a new version, then you have to change the freaking viewer.
I don't really use their viewer very often, I'm just going to say. Not for that purpose, I'll do. That's Chase's job. That's not my job. I make him update all of that stuff. I don't do it. So. Okay, here we go. Are you guys ready? Don't leave my yellow thing out there. They'll steal it. That's mine. It didn't come from the hotel. I brought it from home. All of a sudden, somebody will be like, ooh, this is good. I'll use this on my door. All right. Here we go. A whirlwind. All right, so we already talked about partition speed, and keep all these things in mind. They all stack up together. So we'll be using all these things together as we're going through it. Now I need to talk about hard drives again. I need to talk about 4K sectors. Now this hard drive, a lot of people have seen these hard drives, but they just didn't realize. You've looked at hard drives, you've seen hundreds of hard drives in your hand. Did any of them have any kind of, did you ever just spend time looking at the label? There's no warning, there's no information, there's no nothing on there. There's information you need to do a donor drive and some branding stuff. These, anybody ever see, like they should have drawn a bigger box around these and they should have done more about that. Anybody ever read those? All the newer hard drives since 2010 have got a warning box on them, especially Western Digital's, but other drives have gone to 4K. So this is a 2 terabyte drive, and it had this advanced format drive. It says, to achieve full performance, if you are using Windows XP or multiple partitions and cloning software, you must use the WD-Align software available here. To use your hard drive, you got to go download some software. It's kind of chicken and egg, right? Like, this is my hard drive. I was going to install my OS on it, but now I need this software on another hard drive, on another computer in order to do this. Or if I have a single partition, I can set these jumpers on the end of the drive. Again, we're back to jumpers. Prior to installation of your operating system, or you can use the WD-Align software. These are most of the hard drives you've been walking around with in your hands these days. Now, most people would say, well, I've never done anything, it's always been fine, no problem. And you know why? Because they made everything obsolete prior to Vista. XP, they've been spending years trying to sunset it. XP does not run well on these hard drives. Also, XP is a 32-bit operating system, so 2 terabyte is the highest end it can do. So if you buy a 4 terabyte, 6 terabyte, 10 terabyte, it won't work on those drives correctly because it can't address any of the space, so there's no point to it. But this is a 2 terabyte with advanced format. What happened is they increased the sectors to 4K. So your sector size is 512 bytes. It's always been 512 bytes. But your operating system and all your tools still see 512 no matter what you do, okay? So they decided, well, we're doing a lot of management and we can gain back some things by changing to 4K so that we can move into the future and make our drives faster. And so they made some bad decisions for you again based on that. But the requirement is you had to get rid of anything prior to Vista. So they have been trying as hard as they can. Try to get DOS running, try to get Windows 3.1 running, try to even get XP running on any of the new laptops or any of the new equipment. It's pretty damn near impossible because they had to go to EFI, you have to go to 64-bit, you have to go to good partition tables, and now in order to use the full features, you're still not using the full features. Windows still is not optimized to actually do 4K sectors. Every request is still 512 bytes. So what happens is the drive reads 4K at a time. So the head will read 4K, then it puts it into memory and divvies it up into 512 byte sectors. So then it still delivers 512 byte sectors to you. Now some tools like the DeepSpar actually have a function where it can read the 4K all at once. So that your request, you're not making 8 requests. Because they're 4K, you have 8 sectors, you actually have to make 8 requests to read that all at once. So even though the software would say, I'm making the request, the hardware reads it once, but every request still has to come one at a time. Does that make sense? So the reason that this is a problem, what are they aligning? Anybody have any idea why it's called WD-Align? I mean, imagine an end user who has no idea what anything is. They read this. They have no idea what this even means or why it's there. So when Vista was being made, the whole point was we needed to get rid of all of the legacy stuff we previously had because of LBA blocks. When we went to LBA blocks, we got rid of CHS. So we no longer have any of the requirements we previously had. One of those requirements was all partitions must begin on cylinder boundaries. So that meant on Windows XP, if most of you remember, you could not make a partition butt up against another partition. It was impossible. You could not have 2 partitions back to back. There's always a partition gap, and there's an 8 meg gap that sits in between partition A and partition B. An unusable amount of space, which was a calculation for cylinder boundaries. I could not begin on this boundary, so I had to begin on the next boundary, so therefore I have a gap in between. You guys remember this? All your partitions had space in between them. So Vista, when it's being created, they're like, well, let's do away with all this legacy stuff. We now have the ability in software and a multi-user environment to turn off tools that mess with us. So you can't run Norton Utilities not the same way and not the same tool. You can't run that on Vista, it'll completely disable it. It'll say, oh, I'm sorry, this is disabled, you can't use this anymore. And they do disable and they sunset stuff all the time. Inside the operating system, we have a compatibility list of stuff that won't run. And you just can't execute. And 10 is even more protective. By the time you get to 8 and 10, they shut you down all the time. They won't even let you install a driver that's uncertified. They'll just shut it down, take it out. You see it all the time. Stuff just stops running. So anyway, so what they're aligning here is partition boundaries. The whole point is, let's get rid of cylinder boundaries. We can now put a partition anywhere we want, and we can put two of them butt up against each other in the next sector. So they no longer lose the space. So we're gaining that back. So, but here's why they did it. So in 512 bytes, remember I told you there's all this other stuff around the sector. It's really about 592 bytes. There's all that null space. Some of that null space they're calling a sync DAM. So there's a sync set of information and there's an address set of information that's in there. They call it a sync DAM, and this is a Western Digital document. And so their whole point was they have to have one for every sector. What if I removed those? What if I just said, why don't we just read all 496 bytes and we only have a small sync DAM? You still do not get away from the same amount of ECC. Whatever that ECC was, which is normally 4 bytes, it could be anything else, but it's got to be at least 4 bytes, is now going to be the exact same thing. So you have to do 4 bytes times 8. So you have to have 32 bytes minimum of ECC in order for this to work. Okay? Everybody good so far? So their idea was this: if we whack all that space, how much space do we gain back? Remember, our job as a manufacturer is to increase your areal density, give you more data in the same amount of space. How much do you think that they thought they were going to get back on a hard drive? How much current space were you already losing? Remember I told you 27 to 33%-ish, something in that range. So if they can get something back from that, because they're putting all that in for tracking, now they're getting rid of some of the tracking stuff. So they thought they would get as much as 20% of their space back. They actually thought they would have a 20% capacity gain by removing all of that stuff and then moving that to 4K. Turns out that's not really the case. It turns out it's really about 11% they got back. And I'm not going to say 11% is not nothing, but I mean that's, 100 gigs out of but still, I would say that you're putting yourself in a detrimental state also. You do have to kind of change, because you can't keep tracking everything the way we've always tracked things. But I want you to realize this. You have a bad block on your hard drive. This is a 512 byte hard drive. Your current hard drive has one bad block, and you lose data. How much data do you lose? 512 bytes. You have one bad block. How much do you lose? 4K. Happens all the time. When it goes, it actually marks them. Certain devices you can actually see. It'll mark the whole 8 sectors or the whole set of clusters. So you lose a whole cluster. Think about that. It is 4K for a reason. There's a reason it's not 2K like it is on like CDs and worm drives and stuff like that. It's 4K because 4K is the equal size to a cluster currently in Microsoft's file systems. So when you read them, you're reading 8 sectors at once, and it's one chunk. So now remember when we were talking about bit shifts before? Like if you actually, if we took a plist and we messed with it, now you're like shifting all your data, so you have half a cluster here, half a cluster there. Now you've got a mess. Well, that's exactly what's happening here. So the reason you've got to use the WD Align software is so that you don't have a cluster that ends in the middle of a sector that then would have to be read twice, because the head's only going to read one and then divvy it up. Does that make sense? Otherwise, occasionally it doesn't do the read. I've tested it. Eventually it does. It starts out good. It seems to be okay if you don't use their settings or you do use WD Align and you install XP or something on it. It does eventually eat it. Eventually it does just stop working. It does get corrupt. So that alignment software was to realign sectors or set the drive back to a 512 byte lookalike or something along those lines, so that you don't have this offset. So if you were reading and you read a physical sector and it was 8 and then you were into a second one, there is a problem at some point in time that it corrupts your data. So keep this in mind when we're looking at things. But this is on the DeepSpar, which I don't have that drive plugged in at the moment. But on the DeepSpar, that was that first thing on the menu, that if you had a drive that was a 4K sector, it had a menu option that said long physical sector. That's what these are. Okay? Everybody good so far? Alright, moving on. ZCAV. So CAV is constant angular velocity. That's the spinning of your hard drive. It always spins at the same speed. ZCAV is a test that Bonnie has in Linux tools. So it's an actual testing tool that you can actually test and see what's actually happening to your structure and the whole thing. It does not plot it for you. You have to plot it yourself. This is the plotted graph, and I was just trying to show from a speed standpoint some of the effects of the drive and where the partitions and where the content sits. So these are your drives, and as you see on the outside edges, when you're doing it by speed, it is faster. And the closer you get to the center of your drive, the slower it's going to get, because the less data it can read at a time. So these are some physical hard drives, showing that these are some smaller, like laptop hard drives. And then USB does this. You never reach the speed. Now this is USB 2. This wasn't USB 3. USB 3 is a faster protocol. It can do a lot of things, but it's more like a network protocol than it is like a hardware driver dependent protocol. But USB drives, you could barely ever hit the performance of those compared to a hard drive coming down. So you would always have been faster with a real hard drive instead of USB. The only other problem with USB is this. It's driver dependent, which means it suffers to multitasking. If you're doing something on a USB drive and you are watching a movie at the same time, there is an impact to its time slicing and things like that. And that's why you're seeing this smattering of things that could be all over the place from that standpoint. So you do have an impact with that. All right, so GUID tables. Now I'm just going to introduce these to you. Most of our software processes them. What page are we on? 20, what?
34.
34. So on 34, so I'm just going to show you what a GUID table really looks like. So we've had, up until now, the only thing we've been looking at is MBR. So we've had an MBR. They left it there because it's protective. If something wants to write there, which a lot of tools do want to write there, they left it there to be protected, so that anything that modifies this doesn't actually modify anything in the file system. Then you'll see a header, a certain amount of header, and I've seen blank space. I've seen sometimes blank space up to like 1,000 sectors before they'll actually start their process. So I've seen a couple of things, and it's different if you're looking at a camera, if you're looking at a car, if you're looking at Windows versus Linux. Like, all of these things do something slightly different. They're not exactly the same. But what you have here is you end up having your entries for your partition structure, and then they duplicate at the end of the hard drive. So on any of them that you have that have been formatted as a any kind of GPT structure, go to the end of the drive and you'll see going backwards, you'll have the same structures again going backwards. So they'll use a handful of sectors. Now, they're counting down. It's really max LBA minus 1. That's really what that is. So max minus 1, and you keep going through. You'll see all of your header information there. But any GPT, any current Windows system, Windows 10, Windows 8, Windows Vista, Windows 7, any of those that are all on GPT, that's what you're going to see going backwards. So that way, if a sector fails, the drive automatically knows to come here, the OS automatically knows to come here, and then get the content, and then go backwards. So it pretends it didn't happen. It even tries to rebuild this for you on the fly. Windows rebuilds stuff. That little pretty box that comes up that has a graphic going across, they're hiding stuff from you. There's stuff going on behind the screens all the time that they're fixing while you're doing this. And then your normal partition structure and your partition format. And I broke all this down for people who actually look at this in hex. But our problem is this. Remember that table of 99 that I showed you before? That one that was this. I don't know if you can see it clearly. I showed it to you yesterday, but when you're choosing your OS and you have these 99 options, and we could say, oh, I remember 7 was HPFS. Well, that no longer is the case. Now what we have is this. These are GUIDs, so Globally Unique Identifier. That's what that stands for. So it is a partition table that is supposed to have an identifier that is unique in and of itself to itself. So there is no other number that would be duplicated if it's not the same type of partition. So now you've got to start paying attention. And normally what I do if I'm going to look at something in hex, I just remember the last characters. So I'll then find it, and then I'll look backwards and see if it looks the same. So I'll look for C7, and I know that that's now a Windows. It's also an exFAT partition structure, so those will show up there. And then you'll see those even in other file systems, operating systems, if they're using the same thing. So, but there is a table of all of these. So just be aware that that's there. But once you get to your partition, nothing else changed. So once you get to NTFS string and you're at that spot, then from then on it's the same. It's only the partition structure that changed. You don't even have to worry about it most of the time unless something's corrupt. But there's now multiple copies on your disk, so you don't even have to pay attention to it most of the time. It's redundant as opposed to the MBR, which is not redundant. Okay? So when you're looking at your file systems, we got FAT12, which was floppies. FAT16, which was everything up through Windows 95. That is, you're limited in your file sizes. You could not have a file that was bigger than 2 gigs. So basically, when you get to FAT32, you can now have a 4 gig file, 4.3 or whatever. It's not big enough to contain a DVD. So that's most of the time what your limitation is that you have to chunk your file into sizes. So you can't do a complete backup, like an 80 gig backup in one directory. And then we're to exFAT, which is FAT64. And this is the one that's different. All of these have very similar structures, very similar process. FAT64 is completely different. And the other thing that's different is all of the other FATs you could boot on. FAT64 you cannot boot on. It is not a bootable file system. It's a device file system. So you'll never see it on a bootable drive. What you'll see it as is a thumb drive or an external hard drive that was formatted that. And it was formatted that for compatibility because they made an agreement with Apple. Well, we'll use this driver. Now, that's not why it was created. It was created so that they could have a FAT file system that would have other options for storing data like timestamps and things like that, and GPS coordinates and things that people were sticking in pictures, because pictures made their own EXIF format. They wanted to be able to store that kind of data in the file system, but more importantly than that, their Windows phones were dying. When Windows phones first came out, they were embedded on a FAT file system, and they killed themselves. They would just eat themselves alive because they were on solid-state drives. So you ended up with, I'm going to just skip the basics for FAT real quick. They ended up on a solid-state device inside of the phone. So a Windows phone, for the first 3 or 4 years, you would buy it, a year later it would die because they did not manage where they were writing the data. There was no wear leveling in those devices. Do you guys know what I'm talking about? Wear leveling, where it shuffles stuff around so that you don't write to the same place a million times. When you write to a FAT drive and it updates time and dates and stuff in the same location, it will only live for 18 days. So literally they were pushing it to the limits all the time. So in 2006, Microsoft wrote a new file system and released it at the Windows CE conference or whatever they called it in 2006. And they said, this is what our new phones are going to have, and it's built for solid state. It will make your phones live longer. All those developers that were there were all excited, and they knew it was coming out, and they were going to release it in a few months. That was 2006. What happened in January of 2007? Anybody remember? Why did this no longer matter? Well, so, I mean, that stuff got added later, but that's not what I mean. I mean, I'm more, why would a Windows phone no longer be necessary? Come on, guys. Huh? Because in January of 2007, Apple releases the iPhone. And at the time, iPhones were called the Jesus phone. That's literally what they were called. The only thing they couldn't do is run Flash. Everything else that iPhone did. So the only competitor, so Microsoft up until 2006, there's only 2 vendors, right? Really, technically. I mean, we're going to throw a BlackBerry in there somewhere. But really, it was Palm Pilots, which are mostly black and white. And then they came out with the Trio that was color. But it was a very boring file system based on Palm Pilots for a decade now, right? I mean, it looked like a Newton. I'm not saying it wasn't a great phone. The Trio was a great phone. But it didn't do all the stuff that you want to do it. You could barely see internet if you wanted to try to see internet on it. You could just barely see a web browser. Hope for the best, right?
Nokia's were there, the N95 and so on, but
Flip phones and whatever. There was no phone that was like a computer. The closest thing that was like a computer was the Windows CE phones, because they actually had a Windows CE interface, but they were slow as dirt. They had problems with them. They were dying. And so they had already eaten up their lifespan, because for like 3 years or 4 years, Microsoft had put that out there, but there was nothing else. That was the only real competitor, right? The only thing that was graphical in that same way. So I don't remember Nokia as being like, I mean...
the N95, you could do all kinds of things with.
We'll go back and look at some history and see. But there's no doubt that when the iPhone came out, it devastated the rest of the market. And then Google was already building Android, so it was already on the way. Everything was already heading that way. So anyway, so that's the whole point. So here's what happened. They built a new device interface driver, exFAT, and they had a party, and nobody came. That's what happened. Nobody came to the party until 2009. And then that's when Microsoft figured out something that nobody else could figure out. Microsoft had their hand in one thing that nobody else could do, which was the SD Card Association. They are a big player in the SD Card Association, and originally, what are SD cards formatted as? When you buy an SD card, when you normally bought an SD card in 2007, what was it formatted as? FAT32. It was formatted as FAT32. So all of your items that you stuck that in expected a FAT32 file system to work, and then you could take out your chip and you could use it on anything else, right? Who owned FAT32? Who owns the patents? Microsoft, right? So then you get TomTom and Linux and other people that are putting stuff in there. They sued the crap out of them and ended up paying a huge fee. They're patent encumbered, and so that's why Linux has always kind of had a problem in the world of file systems, because they use EXT on their file systems. But if they want to talk to anybody else and share stuff, they got to talk on FAT32, right? So Microsoft further in patents encumbers exFAT, and it's got some complications in it that are made purposefully to make it hard for Linux or anybody else to put it in there. So, and they had this trade war. They had a battle going on for who owns it. So exFAT as a whole, until the SD Card Association says, well, we need cameras. What's the largest that you can format FAT32 on a Windows system? Think about it. What is the largest partition you can format? 4 gigs is the file size limit. It's not the partition limit. So if you have a 32-bit file system, what's your partition size limit? We've been talking about that already. What's the largest partition I can make if I'm using a MBR?
138.
What's the largest partition size? 2 terabyte. Remember, we have 32 bits in the MBR. 2 terabyte. The reason the GPT exists is to get past 2 terabyte, because we're limited to 2 terabyte, right? That's an actual hard limitation, because you can't count past it. That's it. But that's not Microsoft's limitation. If you have a Windows machine right now and you want to format a disk FAT32, what is the largest size you can format it? Most people haven't tried in a while. Most people don't do it every day, because FAT32 is not really well used at this point, right? So but you do use it on one thing. What do you use it on? So you guys, it's like you guys had turkey for lunch or something. Like, Hey, I'm just trying to get you to put 2 and 2 together, right? How does all this happen? Some is business, some is technical. But all of it is bullshit, either way. It's all bullshit, okay? So here's the problem. In Windows 2000, back in 1999, Millennium Edition comes out, and the Millennium Edition, Windows 98 and Windows 95 can all format a hard drive, if they had one, could all format with no limitation 2 terabyte partitions. We didn't have the drives. They didn't exist. But that's what they did. They could format. And so I could go back in Windows 95 right now, and I've tested it. You can still format. You can format a 2 terabyte partition in FAT32, right? But in Windows 2000, Microsoft decides, well, we're releasing NTFS. And we want everybody to use NTFS. It has security built in, and it has security descriptors, and it's a transactional. And we want to push everybody to NTFS. So we're going to limit FAT32. And Windows 2000 was the last one. That was the first one. They limited it. And you could no longer format up to 2 terabyte. They put a hard limit on your hard drive that you could format. Anybody know what it is? It's 32 gigs. You currently on a Windows system cannot format a fat hard drive under Windows using no other tools, just Windows. You can get a tool and download a tool and make it work, but you cannot do it in the operating system. It's 32 gigs. That's it. It's hard-coded to 32 gigs. We didn't even have 32 gig drives then, but we did not have thumb drives. There was no thumb drives. You understand? All the limitations. There's nothing there. So they put a hard code in it at 32. So if anybody wanted to format a hard drive beyond that, because the clusters in FAT are very, it's here somewhere, here. Once you actually get past 32, your clusters are inefficient, and they start to actually take up a lot more space. Now think about this. You start to write something, and you're doing it to a cluster. If I write a file, okay, so I have a cluster. Let's say I'm on NTFS, right? And I have 8 sectors, right? So this is 4K. Everybody good with this? 4K. I go to write a file right now, and I'm going to write a file that is 1.5K. So here's 512, 512, blah. 1.5K, right? What happens to the rest of the cluster?
It's wasted space.
It's wasted space. Absolutely wasted space. You cannot use it. It's gone. You take a small file, you put it there, it ruins it. You could fill up your drive with small files and lose more space than your whole drive, right? You could have more space left than you have space used, but you can't use it. Absolutely can't use it. Same thing happens here in FAT32. Your cluster sizes now are so big that when you write small files, you could write 20 text files and use up your whole hard drive. So they say inefficient. We're going to cut it off at 32 gigs. You can't use it anymore. Okay? So, and they didn't think we were going to need it at all. So the whole point is that when you get to FAT64, it's now the same combination. They were trying to make it efficient. But FAT64 is the one that can format past 32 gigs. So Microsoft wrote a new driver in 2006 to say, well, now exFAT can exceed all these limitations. I can now make partition sizes bigger than I want. I can make them bigger than 2 terabytes. exFAT is FAT64. It can do it. Okay? But nobody used it. Nobody wanted to pay Microsoft any money, and they had this thing sitting there for 3 years until 2009 comes along. And now camera manufacturers say, well, we would like to write more than 32 gigs to our SD cards. Microsoft's like, you know what? I got something for you. I wrote a driver, and we wrote a whole new file system just to address everything greater than 32 gigs, because our file system, our Windows systems, won't let you format something bigger than that. So can you in a Mac format a FAT32 file system on a 64 gig card FAT32? Can you? Understand what I'm saying? I get a 64 gig card. 64 gig hard drive, and I format it in a Mac, can I format it FAT32 to 64 gigs?
If they wrote their own drivers.
Yep, they did. And they said, screw you guys at Microsoft, we're going to do whatever we want. Can Linux do it? Linux and Macs both can format it. 93% of the market owned Windows. So if you had an SD card and a camera, you were stuck. You couldn't format your card bigger than that. So Microsoft says, we're going to make a new card. Even though it's capable of doing it, all they had to do was add the extension. They could have just said, okay, we're fine with FAT32 until 2 terabytes. It's completely fine. Nope. Screw you guys. $300,000 for every license we sell. If you are a vendor who wants to make a camera who uses an SDXC card, that's what the X is in SDXC, is exFAT. It means the vendor who made the card paid $300,000. The camera who wants to use the card paid a licensing fee of $300,000. The BMW that wants to use an SDXC card in their machine, $300,000. Apple, $300,000. Now it's a volume license. They actually have to pay more. There's more money involved in that because you have a volume license for the quantity on a file system. But you get the whole point. From 2009 on, SDXC cards. My drone, this drone, has a 64 gig card. And in order for this to work, now this is an Android. And patent encumbered. That means Android can't distribute it for free. They cannot build it in. It's in user space. So somebody had to write a driver that will work in this Android file system. Now it's made in China. They probably said, screw you, Microsoft. But in order for that to work, they had to pay for it, okay? So Tuxera, the reason that it exists is this. You know the NT3G... Where is it? Dun dun dun, it was right there. NT3G, I got that right? There's a group that wrote the file systems. I'm going to try to find it, but it's a... I don't remember if I'm spelling it right. Yep, these guys. And you've seen their little logo before. You've seen their stuff. So they've got an agreement, and they make drivers, and they made this file system for Linux, right? And they've been around for a long time. They made the NT3G drivers that people use in Linux and the ones that use in Mac. So when they started out, they made this NTFS3G, and that originally was free. Like they bypassed everything, built their own stuff, and did everything. Well, when they finally got to exFAT, they couldn't do that anymore. They paid Microsoft licensing fees, so now they are a Linux vendor who buys the patents from Microsoft and then licenses them to Linux vendors so that they can use it. They paid $300,000 grand, and they're a Linux vendor, so that stops Ubuntu from having it unless it's in Fuse space. It can't be part of the driver system, so it can't be embedded in it. You guys getting my whole point here, right? So exFAT is a file system that we have to deal with that's on all these embedded systems, and it was mainly built around the idea, like it was ignored for years until the card manufacturers and the SDXC. That's what's driving it. Here's the ironic thing. SDXC, okay, we'll get to this. We'll get to your Nokia, which you're showing to me on an Android. But the whole point is this, is that we got to a spot, at least, where now everything is paid for. Even in the Linux world, there's a lot of things that are paid for that they can't embed this stuff and they can't do anything. There is a free driver somebody wrote who does not live in America who said, screw you, Microsoft, I'll do whatever I want. I'm not going to live under your patent laws. But ultimately, even though it was capable, that it still didn't, we still didn't use FAT32. We're now at a completely different file system. But it's not a bootable file system. So you're only going to see it in certain things that you have to do recoveries, which are mostly thumb drives or some external hard drives. And that's it. That's hard. I hardly ever see it. How many times do you guys see it? How many guys have you seen it in a real recovery or a real lab or a real forensics case? It gets corrupted very easily because the manufacturers who make it don't know how to manage it. So the camera manufacturers who are using FAT32 had to bring these guys back who wrote drivers like 30 years ago and try to get those guys to start rewriting stuff to work with the SDXC cards. So you can actually delete a picture in a camera and it'll corrupt it. So in the process, they don't know how to manage it. But here's the real irony. exFAT was built around the idea that we no longer had a 2 terabyte partition limit. It actually is very similar to NTFS in the fact that it could make a huge partition that is not limited. But because it goes in a camera, they can't do GPT. So the cameras can't do GPT, they do MBRs. So they backwards made it compatible back to the MBR. So now it's 32-bit again. So it's now encumbered again by 2 terabytes. So all those SDXC cards, even if we get a 2 terabyte one, it won't work beyond 2 terabyte. That's the biggest it'll be ever. We're not there yet, but maybe in 10 years. I mean, it's going fast. I mean, we're already up to, I certainly have cards that are 1 terabyte now. 512 is on the shelf. So we're not that far away from that standpoint. Maybe 3 or 4 years, maybe. I'm sure that already exists. We just don't have it. So anyway, so that's the story behind exFAT and dealing with exFAT. The file system stuff is all embedded at the beginning of the file system in a table, and it also includes local GPS coordinates, local time zones. So it's a forensics, user's dream from that standpoint. It'll tell you where they were when they took a picture, where it was when it was written, where it was, and the local time zone. So you can figure out where it is. Right now, we don't know those things. When a user travels, we don't know where he was. He resets the time on his machine and then resets it back. We don't know where he was. There's nothing embedded there that helps us. There is in the picture. Anyway, so that's the whole point. There's a lot of things that are not supported that are built. It actually has security in a transactional file system, but nobody's using it. And so really you're just recovering raw data again. So all your FATs are really raw data. Now I'll tell you the other thing is FAT up to FAT32. If you lose your file system, there's not an easy way to recover anything except carving. Because the FAT tables are really small and they're at the beginning of the drive, they get overwritten. But there's a chain of clusters from a directory structure to another directory structure where all the data inside of the directory all exist in the same chains. And they're done by the dot and the double dot. Do you know what I'm talking about? So inside of DOS, inside of your file system when you're at a prompt, and I'm sitting here, and I do dir. Well, I'm in XP. These are fake. These don't really exist. So that dot is current directory, and the double dot is the directory above me. Those don't currently exist. They're fake inside of XP, NT, Windows 2000, and so on, right? But in earlier versions of anything with FAT32, they're embedded and they're actually in the file system. So between here and the next directory structure, you search for your dot and your double dot, and everything from here to the next directory structure is all in the same directory. Right? There's only a handful of tools that do that and do it correctly. Everybody else is just searching and carving files. Get data back for FAT. You can see it on my screen right here. This one right here. It's made by Runtime Software. It's called Get Data Back for FAT. It will recover between those two dots, and we'll try to break that up into directories. So it will actually identify those as directories, so at least you'll know that data goes together rather than just a pile of raw data. So if you're doing FAT drives, that's my suggestion. And the other one is Ncase. Actually has a script that actually works. So Ncases will do it as well. I'll have to check Xways and see if Xways actually does dots to dots. I would be surprised if it doesn't, honestly, because Stefan's a pretty smart guy. But outside of that, those are your basic tools. I really don't go outside of those because there's nobody writing FAT tools anymore. That's pretty rare. They're all moving ahead. So now if you needed to do exFAT, RStudios. RStudios will do exFAT. It'll be the cheapest recovery tool that you'll have, and it'll do exFAT. So any of your FAT64 stuff, go to RStudios and do it there. It's all supported. Okay? Everybody good so far? Just make sure everybody understands that. I don't want to waste a lot of time on the labs and stuff for the simple stuff, because those are simple things. All right. And Windows, all those Windows drivers are now embedded in Mac OS, and they have been since 2010. So Mac OS X added them 8 years ago. So they are all supported in Mac OS. So you would want to format something exFAT, you can do it in a Mac, and then you can do it over in a Windows machine. And this is the only time Microsoft went back and they added a new driver in Windows XP. There is an update for Windows XP to include SDXC cards. It actually does exFAT. They said they would never do it, but because of this release of X cards, the exFAT cards, they went back and wrote a driver, and now XP actually has a driver so that anybody using that for SDXC cards, it will work. So they did update it. Okay? All right, let's talk about NTFS. Let's get to the real meat. First thing I want to debunk is this idea that there is a NTFS mirror. Everybody believes, you see it all the time, it says, you'll actually see that there's a master file table copy. And so people believe that there is a master file table copy and there's another copy of the MFT. Well, that is not true. There is only one copy of the MFT. Now, the master file table keeps track of all your files and your folders together. These are 4 records. They're 4K. They are pointers to where the tables exist in case of failure. So these are written, you go to the middle of your partition, you -1 divide by 2, and it's written right there. You'll actually get 4K that will tell you where the pointers are for the other files that might have been lost because these pointers were corrupt in the file system. There is no other copy. Does this make sense to everybody? The master file table is a binary list of all your files. There is only one copy for every record. If something happens to one of those records, that record is gone. You cannot get that file back except by carving. Understand? All right. So this is what we're looking for all the time. Whenever I'm looking at a hard drive, you saw how I look at IC07, I know it's NTFS. Well, the next thing I would normally do if I couldn't find a file system or I was looking for a partition structure is I would look for this string. And so I would look for this at this offset. So you can actually see it here in hex. So you can actually go through this and search for it in hex from this string. And I'm looking for NTFS. When I find that, I know that's the beginning of my partition. That's where I start processing my data if something's corrupt and I don't have a partition table. Okay? So keep this in mind. NTFS is where that string is. It's at sector 63 on the DeepSpar on the things that we were just looking at. Now, NTFS is you can think of it as kind of like a bunch of little mini databases. It is a structure, and there is a format for that structure called the New Technology File System. We've already talked about that. It all came from OS2. It exists from OS2. These things all existed in OS2. They have been there since 1983. These are different versions along the way, but they're still there. Now, let's talk about what we need. Inside of the NTFS structure, these are the records that they have. These are symbolic. They're not an actual file per se. They're symbolic in their name. This is a bunch of binary data that is gathered together by a data delimiter that has $MFT associated with the records together. But the records are all one binary set of records by themselves. There's not an actual file per se. But you'll see it in the file systems when you start to extract them. There'll be one called $MFT. The operating system, while it's running, never shows you $MFT because it's virtual. It doesn't really exist. Microsoft puts dollars in front of all of their system attribute items. Anybody know why they put dollars in front of them? Why are they using the $sign? It's a really easy way. Microsoft likes dollars. Did you not? All right, moving on. So we have the MFT, which is the most important table that we need. We need this table. The next table is the mirror, we don't really need it. If we can find the MFT, we do not need it. But this is also only 4K. It duplicates first 4 records of the MFT, which are pointers back to itself, to make sure that you know where to find it. Okay? And then it hides that further down on the disk so that it knows where to look for it. The log file, there's a lot of meaty stuff in here, and forensics people love this, but we don't need it. But the log file contains a lot of things that show records deleted, what was used, like it's an active running system. Dollar volume, we don't need it, but that gives us our file volume name. The volume name where it said like Francisco Pelamonte on my hard drive, that's stored here. And there's one other thing that's stored here, which is called the dirty bit. Does everybody know what the dirty bit is? Not dirty bird, the dirty bit. So a dirty bit is when your system crashes and it comes back up, the bit that tells it that your system crashes is there. It's stored in that file. So that's what starts ScanDisk. When it hits that, ScanDisk starts to run. Now what happens is it's off, it's 0. When your system boots, it sets it to 1. If you shut down correctly, then the system has enough time to change it back to 0. Then when it shuts down, it's okay. If it crashes, it was already 1, and it never got reset. So that's how it knows it crashed. Does that make sense to everybody? Everybody clear? So that's where that is. It sits there. Attributes. Technically, we don't need attributes for recovery. So really all I want, right now, all I want from this screen is this, and maybe that. Outside of that, I don't need any of this. This has a volume serial number in it, and some names. The root folder. The root folder is always technically lost when a crash or something happens. So the only way you can recover files from a root folder that's lost is to carve them. There's no other way to get those normally. But at least from this standpoint, there is actually a structure, and we can recover those. There's not usually a lot in the root folder that's actually valuable that doesn't already have a name that doesn't exist in the MFT entries, though. All right, bitmap. This is the rest of the records from here down that they're already reserved. So in the records that we're looking at, $bitmap shows a list of free space and unused clusters. This is the one that when I did the DeepSpar, and I told you I'm getting file records, index records, and bitmap, this is one of the files that it got. Because I can do allocated and unallocated. That's the file. Everybody good? Glossy-eyed people. Everybody understands, right? The files that I need to recover a file system. Bitmap. I don't need boot sector. Bad cluster only exists because when they wrote NTFS, we had MFM and RLL drives. When they first started writing NTFS, there was no IDE. It still happens every once in a while. A cluster goes bad and it marks it bad. And ironically, this is not a joke. You know where I showed you file in the record name and it said file? Well, what it puts there, if it has a bad cluster, is BAAD. So it's bad. It's like, that's not a joke. It's real. They really put BAAD and then mark the cluster bad. And so there shouldn't be hardly any of these, but it does come up from time to time if something bad happened. $secure. $secure is the file that knows all of your security for whether or not Bob can go to Susie's files. So if Bob doesn't have the key to go to Susie's files, and I'm going to show you all this in 10 seconds, we're going to do a real thing. I'm going to show you on a screen application for every one of these things so that you can know how it works in your file system. You're going to see it real. Bob and Susie's files, and then there's an uppercase, extended, and all these. We don't need these for conversion or anything. I don't need security. Now remember when I said the blue screen? If you plug in a hard drive and it blue screens on Windows but you go to a Mac and Mac doesn't show all the stuff, that's because the Mac doesn't mount these things. So you don't get this, you don't get this. All you get is this, and you get this. So the bitmap and the MFT volume and the volume name. The rest of the stuff is pretty much ignored. All the other file systems ignore all of those other things. All the other OSs ignore those on this file system when you plug them in. Everybody understand? Yes. Okay. All right. So let me show you something. So this is a real thing. And I want you to look at this picture. Everybody can see the text okay? Can you see? This is a Documents and Settings folder. And in that folder, there's a dude called Snow Cowboy. This is a real thing. There's really a guy who actually gave me a disc called Snow Cowboy. So Snow Cowboy, I've plugged in his hard drive. Now I went to the DeepSpar, I imaged his drive, I got a recovery, I came over to my Windows machine, and I plugged it in. And you can see right here, I have a RAID array. Here, his drive says my label is C, but it's really my F drive. And then here is his hard drive. And now I have a directory called Snow Cowboy. Now Snow Cowboy, when he set up his user, it asks you, there's a box that pops up, and it says, would you like to set all of your files to private use? Or private, or whatever it is. You guys know what I'm talking about, right? It'll either do that, or if you add yourself to a domain, then it automatically adds a RID and a SID, and it automatically makes your files private to you, or an administrator. So you have to have what's called ownership. The rights on a server called ownership. You guys okay so far? Right? So at some point in time, Snow Cowboy said, yes, I want to make my files private. So now if I go to that directory and I click on Snow Cowboy, I don't have rights to Snow Cowboy's files. Right? I've done a recovery. He's got stuff on the drive and I want to get it off, but I don't have rights to Snow Cowboy's folder. And it tells me access is denied. I get an error. Now this is a directory Opus window, but there is a Windows one that would actually just say the same thing. Error, I do not have access. Access is denied. Right? Now, here's what I see all the time. So I can't get into Snow Cowboy's folder. So this is what I see. And I've seen the Geek Squad do it. I see everybody do it. All of you have done this. I promise. Every one of you have done this. You want to copy this hard drive. Let's say a president of a company doesn't trust his own IT guys. So he calls the Geek Squad. And you're working for the Geek Squad. And you come on over. And he says, I would like you to upgrade. I want a bigger hard drive. And I want a new operating system. I want you to upgrade my machine. So the first thing you have to do is take the hard drive out, put a new hard drive in. And then start upgrading the operating system. Right? Or take the hard drive out, erase the hard drive, do something else. But everybody does this. I want to copy this hard drive to the new hard drive. So they hit Control A. Everybody does that, right? Control A. Then they say Control C, copy. Or they right click and say copy, right? They right click and then say copy. Do this. And then I come over here and I paste it, right? Into the second hard drive or wherever it is. This is Snow Cowboy's hard drive. What happens when it gets to the Snow Cowboy directory? What error do I see?
Access denied or unreadable.
Access denied, unreadable. What do you say? Access denied. What do you say? You get a permission error. You get. What do you think?
Access denied.
What do you think? Failed to read it. What does failed to read it mean? Okay.
I don't think you're going to get it either.
He is correct. It will skip it. You will not get an error. You won't see an error. You only implicitly get an error if you actually click on the directory. As far as the system is concerned, you are Bob, and you don't have right to Susie's stuff. So you don't have a right to even look at it. So it does not give you an error unless you explicitly attempt to actually access it. So there will be no pop-up box. There will be no log. There will be no error. It's no different than you trying to access system volume information on your hard drive. If you
take ownership, am I right? Before you even got
right, so you can take ownership, and there's some tricks with take ownership because sometimes you try to take ownership and you can't take ownership of a file till you already have ownership of the file. So you have to run take ownership 2, 3. You have to run it till there's no errors, right? You have to keep doing it. And on a big directory structure, that could take a really long time too, right? Like a half hour, an hour, whatever. I can save you all of that time. You never have to do that again. You don't have to take ownership. You don't have to. All you need is something that reads MFT and then just get the files. You don't have to take ownership. Forget security. There's no security. That's a figment of your imagination. There's no such thing. Do you think a guy writing ransomware who wants your $50, who attacks the Atlanta network and encrypts all their machine, do you think he needs security? They had domain security on their machines. All the people who sat in the Atlanta office who got attacked, you guys heard about all this, right? The Atlanta citywide network got attacked a month ago and held ransom for $50,000, and they refused to pay it, and they paid SecureWorks to come in